हेलो। ओ राइट यार, सर आप कहाँ पहुँचे? हाँ, आप बस स्टैंड पे हो, मतलब निकल गई? अच्छा, कांसा चौकड़ी तो कितने बजे आएगी बस? कांसा चौकड़ी कहाँ है? कांसा चौकड़ी कहाँ है? ठीक है सर, चलो मैं उनको रहने दो, तो मैं उसको बोलता हूँ कि सर मैं आज नहीं ला पाया। कल तो मुझे याद ही नहीं रही सर। सॉरी, मुझे भूल ही गया मैं तो। हाँ, कोई बात नहीं, चलो मैं बोलता हूँ उनको। हाँ, ठीक है, ठीक है सर, ओके। चलो ठीक है सर, ठीक है, कल। तो हेलो एवरीवन, let us good morning. So let us start today's session with this question. तो ये जो क्वेश्चन है आपके सामने, इट इज अरेंज द फॉलोइंग कार्बोनिक एसिड्स इन इंक्रीजिंग ऑर्डर ऑफ एसिडिक स्ट्रेंथ. Could you figure out this question? तो इसमें देखो, आपको क्या देखना है? एसिडिक स्ट्रेंथ of the, because to determine the acidic strengths of these carbonic acids, we have alpha hydrogens. In second case, these are the alpha hydrogens. In third case, so tell me which one has highest acidic strength, or which one can be removed as H plus. जी सर, जी, ओके, ओके। कोई नहीं, मैं उनको पहले फ़ोन करता हूँ, चेयरमैन को ना। जी 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 सर। मुझे अपन, ठीक सर, नंबर सेंड कर देना सर, प्लीज़। थैंक यू सर। यस बेटा। So which one you consider as the most acidic hydrogen? Which one? Very good. Because there are nitro groups, and nitro group has strong electron withdrawing influence. Therefore, the hydrogen is more acidic in on this carbon. Very good. And then one, if fourth you identify, you will get the answer. Because यहां पे जो ये कार्बन है सेकंड में, दैट इज attached to two withdrawing groups. This one and this one, they are attached to only one withdrawing group. तो इस तरह से second one is the next, and then so fourth is, in fourth case these hydrogens are most acidic, and then it is followed by second, and in first and third, you know, first has these bridging groups, bridging hydrogens. So CO group, here see, both the CO groups are adjacent to each other, and then there is hydrogen. And if we talk about this hydrogen, it is least probable to be removed, because you know it is difficult to remove any group from the bridging carbon. That's why third is least and fourth is most. So option D is correct. This one, the correct order of stability of the following. Okay, this question we have done, right? We have discussed this. Okay. This one, we have done this one. What about this? Okay. This one. Okay, let us discuss this question. Arrange the following pairs that represent the resonating structures. Yes, but so first one is not a pair of resonating structures, because there is a shifting of H plus ion from O negative to OH. Hydrogen from oxygen is shifted to nitrogen. What about this? Here again, this pi bond, if pi bond shifting takes place, then this carbon has a positive charge, so one which is attached here, that should have negative sign, but it is not like that. So it is also not a resonating structure. What about this? Because in resonating structures, there is a shifting of pi bonds only. Sigma bonds will not break. So in this case, if this pi bond shifts here, O becomes neutral, carbon becomes positive. So R is right. It is a resonating structure. What about this? Here, so see, O negative, that form double bond, and N has positive charge that neutralizes. That means both are resonating structures. That means R and S are resonating structures. Yes, beta. Which compounds will show aromaticity? Okay. See, thiophene, it is an aromatic compound because there are 6 pi electrons, because one lone pair is considered in conjugation. So there are 6 pi electrons. It is planar. In second, this is sp3 hybridized carbon. Two, 1, 2, 3, 4, 5, 10. System is conjugated, 4n plus 2 pi electron rule is followed. That means it is also aromatic. And that is 1 and 3. So D option is correct. Because in fourth case, there are 8 pi electrons. First of all, there are 8 pi electrons, and at the same time, it has tub shape structure. It is not anti-aromatic, it is non-aromatic. It is like this. It has tub shaped structure, it is non-planar, and therefore it is non-aromatic. So that means option D is correct. Yes. X may exist in a tautomeric form Y, and that react with methylamine to form Z. So what is the structure? First, make its tautomeric form. Let us say it is like this. Because only one form can be tautomerized, because this is enol on both sides, but only one OH can be treated as its keto form is only one. So let us say this is the keto form. Now methylamine. So whenever we have keto group and reaction is with amine, so there is a removal of H2O and there is formation of a imine, substituted imine, that is also called Schiff base. Okay, so tell me which one is the right option? Yes, option A is correct. Because in this case, it is considered as both the forms are keto. In this case, it is at CH3 NH, means there is a single bond, but there should be a double bond. In this case, even so, there is only one option which is in favor of the reaction. Okay, already answer is given, but let us discuss it. Arrange the following molecules in decreasing order of rate of solubilisis. See, in B and C, there is this leaving, this is called tosyl. It is very good leaving group, but as it is attached to the bridging carbon, it is difficult to remove. That we have already discussed. Now, that's why A is most reactive towards solubilisis. Solubilisis means like hydrolysis. So, if solvent is water, that is called hydrolysis. If there is any solvent, that is called solubilisis. So, removal of this group from bridging carbon is difficult. Now, B and C both are bridging. So, in first instance, we get the answer A is greater than BC. So, if you know A is greater than BC, you will approach the answer, because there is only one option where A has more reactivity, more rate of solubilisis than B and C. Anyhow, why B is more than C? Now, see, both are attached to, in both cases, this group is attached to bridging. But in this case, you know, ring is bigger. Here there is only one, ring is smaller. अब ऐसा क्यों होता है कि ब्रिजिंग कार्बन जो हैं they are difficult to remove? Because after removal we get carbocation. Now, carbocation has planar structure, but in ring it is difficult to attain planar structure or strainless rings formation. So, when ring size increases, strain is less. If ring size is small, strain is more. That's why B has greater rate of hydrolysis, solubilisis than C. So, if both are bridging, then we see the size of the ring. If, because means atoms between the bridging carbons. There are two atoms between the bridging carbon. Here there is only one carbon bridging between the bridging carbon. So, if number of carbon atoms increases between the bridging carbons, the rate of reaction increases. So, tell me why D is more stable, because already answer is given. Why D is most stable? In all the cases there are opposite charges. Actually, negative charges should be close to each other, then that is the stable resonating structure. So if you consider separation of opposite charges, then A should be the right option. Because positive charges are on the smaller rings, or they are almost in the same distance, because there are two carbons in between, positive and negative charge in A and D both. There is one more thing which is making it more stable. Yes, that is the right reason. See, in first case, this ring is aromatic, but this ring becomes aromatic, and this ring becomes anti-aromatic, because there are 4 pi electrons, lone pair and pi bond. In this case, this ring is positive 1. Obviously, this is considered as pi. So this is 1, 2. This becomes an aromatic, and this becomes anti-aromatic. Here, again, this becomes aromatic, this becomes anti-aromatic. But in this case, pi bond, negative charge, pi bond. Negative charge is common to both. That's why both becomes aromatic. And that's why D is most stable. Okay, this is already we have done. Yes, carbocations are the intermediates. So they are stabilized by resonance, inductive effect, hyperconjugation. So the cation that can be stabilized by hyperconjugation is C. Why? In first case, second case and fourth case, they are not stabilized by hyperconjugation. Why is it so? Yes, because in first case, if you shift it is like this. This has no alpha hydrogen. That means no hyperconjugation. In second case, pi bond shifting we get this product. Again, no alpha hydrogen. In third case, there is alpha hydrogens. So hyperconjugation is possible. In last case, this positive charge that is not at all in conjugation with pi bond, but there is again no alpha hydrogen. and that's why there is no hyperconjugation in first, second and fourth, and there is hyperconjugation only in case of third. First read the statement. A homogeneous mixture of P, Q, R is spotted on a thin layer chromatography plate, TLC plate, that is made up of acidic silica. The spotted TLC plate, there are three spots, P, Q and R. As the eluent rises up the TLC plate, the compounds of the mixture separate and travel to different distances. So the developed TLC plate is shown below. These are the three spots. So based on the and this TLC plate is placed in a closed jar containing diethyl ether as the mobile phase. We have diethyl ether as the mobile phase. So tell me, out of P, Q and R, which one moves faster or which one moves up? Obviously solvent should be somewhere at this point. So with solvent, which compound will move fastest, P, Q or R?
So which are the least mass?
Least mass. Anything else? Diethyl ether is somewhat non-polar, right? So the like dissolves like. So the one which is means less polar will move faster, right? Okay, so sorry. So options are: separation of compound depends upon the degree of adsorption, right? Compound Q moves faster than P. That's wrong, because P will move faster than Q. Compound R will move slower than P and Q, right? Because R is more polar due to the presence of NH2 group, and in Q there is ester group. Compound S has both groups, so that is expected to, because one is NH2 is electron donating group, OCH3 is also electron donating group, both donate towards the ring, and therefore compound S is expected to move slower than the compound R. So in this way, we have most means सबसे ऊपर कौन सा होगा? P, then it is Q, and then R. And at the end it is S. Wait, yes. So Newman projections P, Q and S are shown a PQ, R and S are shown. So which one of the options represent the identical molecules? Yes. तो कैसे करेंगे इसको? Are you trying?
Yes.
Okay.
So option C.
Q and R. Let us check. In first case, you know, it is central carbon. This carbon is attached to two methyl groups and one ethyl. And the other one is attached to two methyl and one OH. So it is your P. Now Q. In Q case, this carbon CH is attached to CH3OH and CH2 CH3 and another carbon is CH2 CH3. So this is Q. What is R? So this carbon is attached to 2 CH3, 1 OH, another carbon is attached to C2H5 so these are identical, Q and R. If you draw S, so we have CH3 CH2, this carbon is attached to one OH, one C2H5 and CH3CH3. So Q and R are identical. Very good. Which amongst the following are aromatic?
Yes.
Option A.
Yes.
Okay. In first case, there are 2 pi electrons. Planar aromatic. In this case, again, it is aromatic, 6 pi electrons. Okay, so that means 1 and 2. Yes. Correct order for the relative energies of the following sawhorse structures. First of all, identify the staggered and eclipsed conformations. If you see first one, this is fully staggered because CH3 groups are opposite to each other. If you look at fourth one, CH3 groups are on same side, so it is fully eclipsed. First one is fully staggered, fourth one is fully eclipsed. So that means fourth is, because it is relative energies, so it has, fourth has highest energy and first has lowest. So fourth highest, first lowest. That means ऑप्शन ए एंड बी में से कोई करेक्ट होगा. ओके, नाउ नेक्स्ट पार्ट. With respect to CH3, we have H, and with respect to this CH3, again we have H. This is partially eclipsed, or we can say gauche conformation. It is partially है तो ये eclipsed, but it is partially eclipsed. What about this? Again CH3 H, CH3 H. Again it is eclipsed but partially, so it is also partially eclipsed. Why this is fully eclipsed? All the three, 2, 3 and 4 are eclipsed conformations. But in this fourth case, both the methyl groups are close to each other. But in second and third, methyl group is closer to hydrogen. Methyl group is closer to hydrogen. And that's why A is the right, because third and second have same energy, because both have same configuration. That's why A is the right option. This question we have done yesterday. What is the answer? Option A. Right, because there are three stereo centers: CH3, H, OH, H, OH, C, H, double bond CH, CH3. So obviously this is also contributing geometrical isomerism. This is chiral center, this is also chiral center. So number of stereo centers are 3. So number of isomers, stereoisomers, when ends are different, is 2 raised to power n, means 2 raised to power 3, so 8. Among the haloarenes shown below, correct order of reactivity for the substitution reaction with NaOH. What is the order of reactivity? Option A. Yes, because in second there is nitro group at para position with respect to chlorine. Actually it is a nucleophilic substitution reaction. So withdrawing group increase the reactivity. So nitro group at para position, nitro group at meta position, and then methoxy group at para position. So overall this is electron releasing group. This is somewhat electron withdrawing, but minus I effect is least because it is away from chlorine and it is strongly electron withdrawing. So second should be most reactive, followed by third, and third, because there is a weak minus I effect, so third and first have almost same reactivity and fourth is least. Which one is aromatic? Option A. First one is aromatic because what is the name of this molecule? Yes. Second is also aromatic because lone pair is not contributing towards aromaticity. There are 3 pi bonds. This one is pyrrole, and in this case, this nitrogen is sp3 hybridized, and there are only 4 pi electrons. So M, N, and O are aromatic. This is already we have done. Okay. So any topic from your side which you want to discuss in GOC? ऐसा कोई भी टॉपिक है आपके? और नहीं?
So,
यस बेटा.
so ना IIT में मतलब क्वेश्चन थोड़े इजी लेवल में आएंगे.
हाँ, इतना टफ नहीं होते, बट एरोमेटिसिटी पे क्वेश्चन मैंने देखे हैं. देयर आर सम क्वेश्चंस.
Yes.
तो एरोमेटिसिटी वाला टॉपिक जो है वो इम्पोर्टेंट है. एसिडिक स्ट्रेंथ, बेसिक स्ट्रेंथ, कल ही मैं देख रहा था क्वेश्चन. ओके. So tell me, if it is Br2 gaseous reacting with alkene, what is the product formed? Actually, if it is Br2 in the presence of CCl4 or simply written as Br2, then you are right, because that is simple product formed and it is a test for unsaturation. But when we have Br, because you know normal state of bromine is liquid. So gaseous bromine means bromine at high temperature. So whenever any reaction taking place at high temperature, the nature of reaction is no substitution, free radical substitution. ये helper word I think मैंने बताया था आपको. Whenever there is a high temperature, electricity, light, peroxide, electrolysis or any radical initiator is there, then reaction is free radical substitution, so it leads to the formation of this product. Free radical substitution reaction takes place.
So what if the Br2 is in excess?
Even because when temperature is high, first of all addition takes place, okay,
Yes.
and then at the end, there is a removal of HBr, and ultimately we get free radical reaction, because addition reaction is not at all possible if Br2 is in excess, like Cl2 at 773 Kelvin, पढ़ा होगा आपने. नॉर्मल Cl2 ऐड करते हैं तो देर इज एडिशन, बट इफ इट इज at high temperature or in the presence of light, then we get free radical reaction. ये आप किसने भेजा अभी? करेक्ट स्टेबिलिटी ऑर्डर.
तो मैंने
Okay, so let us discuss this question. Okay, one second. Okay, the question is the correct order of stability of the following carbocations. So obviously most stable carbocation is, I hope, C. And there are two options of C. Why I preferred C? Yes, because it is aromatic. Then I will go with A, because there are 3 phenyl groups which stabilize this carbocation, right? C, A, and then we have, because that is stabilized by resonance actually. In B, there are 2 phenyl groups, but in D, in A and B, they are stabilized by resonance, but D is stabilized by hyperconjugation, inductive effect and hyperconjugation. That's why it should be C, A, B, and then D. Understood?
yes. Sir, I have one more question.
Yes. बोलो बेटा.
Yes, I'm saying. Yes, yes.
Okay. Okay, one more question. Okay. Okay, the possible number of stereoisomers for 5-phenyl pent 4-ene 2-ol. So let us draw its structure first. 5-phenyl pent. So So 1, 2, 3, 4, 5. So 5 phenyl, four ene, and 2 ol. So that means this one is chiral center. And this one is again a stereo center. So there are two stereo centers. So number of stereoisomers because ends are different. So total number of stereoisomers are 2 raised per n. This 2 raised per 2. So there are 4 isomers. Just look at, yes, beta. Sorry, I didn't get. Structural formula? No, because these are stereoisomers. Because see 4, 5 that form double because of double bond form geometrical isomers, right? And in our second position, that is chiral center, so that will give dextro and levo. So they are not structural isomers actually. Okay. Yes, for structural isomers. This formula is for stereoisomers only. 2 raised to power n. For structural isomers, we have to draw the structures. There is no formula as such. Okay. Only we can get stereoisomers from this formula. Yes, madam.
So like aromaticity is so like aromatic compounds are more stable than the resonance compounds.
Yes, aromatic compounds are more stable.
So what about mesomeric
Mesomeric compound means, see, even in aromatic compound there is resonance, mesomerism. Okay, so more is the resonance, more is the stability of the compound. Okay, in aromatic hello, yes.
So are mesomerism and resonance same?
Mesomeric, yes, that is same. Mesomerism means resonance. Okay, let us solve this question. Tell me, which of the following is not the product of dehydration? Yes, because when we look at the structure, we get alkene by beta elimination. So this is alpha carbon, So either we remove hydrogen from this carbon, means these are the 3 adjacent beta hydrogens. So we get A, B and C alkenes. Yes, what are the products formed? नहीं? Are you trying? Okay. Hmm. What is the role of NaNH2? So what is the product formed? Actually, NaNH2 is a strong base. Therefore, it will abstract hydrogen from it. And then CH3, CH2Br, there is a removal of sodium bromide. जो आप बोल रहे हो, that is sodium in liquid ammonia. In sodium in liquid ammonia give alkene, but it is NaNH2. Sodamide, it is a very strong base that can remove hydrogen easily, and therefore we get this product. This is X. So it is but 1, 2, 3, 4. But 1 ine. Then again there is NaNH2 liquid ammonia. Second hydrogen is replaced, and that sodium is soda salt that gives CH3CH2. So we get Hex 3 ine, means D. First we get but 1 ine, then but 3 ine. Yes, what is the product formed in this case? Option C. What about others? You have alkene. First of all, alkene will react with HF. Now I hope you got an idea. Option? Yes, it should be A. First, the carbocation will attack and there is electrophilic. It is Friedel-Crafts alkylation. So in this way, the benzene ring is attacked by this particular carbocation, and we get A as the product. Yes, but okay, at 0 degrees Celsius we get this product, right? If we increase the temperature, the carbocation is not as stable that will attack at, so there may be some time there is addition of fluorine on this side as well, because it becomes highly reactive. This carbocation is stable at low temperature. Okay, and once fluorine is attached here, then reaction is not easier to take place. So carbocation is stable at a low temperature, and then it will attack at the ring, benzene ring, and leads to the formation of electrophilic substitution reaction. Because attachment of fluorine is not easier to attack, because fluoride ion can hold its negative charge. But if reaction temperature is high, then reaction is fast, and therefore instead of reaction with benzene, HF will add on to alkene only, and therefore we get fluorocyclohexane rather than the substitution product. So temperature should be low. Okay. Cis-2-butene. So which reagent is used? Yes, what is the name of this reagent? This is Lindlar's catalyst. What if we use sodium in liquid ammonia? yes, then it will give trans product. So that's all about today's session, and next chapter is aldehyde ketones carboxylic acid. So it is better to send me some questions related to that topic, is in which you have doubts, so that I can focus on those topics only. Because in aldehyde ketones carboxylic acid, main focus is on aldol and Cannizzaro reaction. तो क्वेश्चन आता ही है, और आइडोफॉर्म reactions to some extent, then tolerance reagent failing solution, or addition of ammonia derivatives. In carboxylic acid, it is simple, just like alcohol. Reactions are just like alcohol. So if you have any doubt in that topic, you may share with me. तो हम फिर उन टॉपिक पे फोकस करेंगे मेन. So next class will be of aldehyde ketone and carboxylic acid. And if you have any doubt in GOC or any topic, वो हमने इसमें रखे हैं कि नहीं, that doesn't matter. कोई भी क्वेश्चन आपके पास हो, कोई भी डाउट हो, you may share with me. अगर मैं आंसर नहीं करता हूँ तो just remind me. तो we will discuss. ठीक है बेटा? ओके, बाय बेटा. यस बेटा. लास्ट वीडियो. ओके, आई विल शेयर. ठीक है. ओके ओके, श्योर. बाय बेटा. वेलकम.